Good morning, everyone. Welcome. My name is Jeff Brown, and I'm the Grails practice lead at OCI, the home of the Grails team. So I know all of you have heard a lot about OCI already this week. Please, if you haven't already, come by our booth, our table out in the hall, and let us know whatever it is we might be able to do to help you out around Groovy and Grails stuff. I won't repeat all of the information that I have in previous sessions, as well as some of the other folks from OCI. But come see us if you're interested, or if there's anything at all that we can help you with. And remember that today at I think 3:20 is the time. Whatever time the drawing is going to happen in this theater, we're going to do a drawing and giveaway in Apple TV. So if you haven't signed up for that yet, please come by the table and fill out a registration form and get yourself entered into that drawing. And we've also got an Apple TV set up out there to demonstrate some really cool stuff you can do with respect to writing Apple TV apps in Grails, which is really interesting. So definitely come by and talk to us if you haven't already. So I want to get right into the technical content. So I'm going to talk about polyglot web development with Grails 3. So we'll start that discussion with just a little bit of talk about definitions and what polyglot is. So polyglot means many languages. So we're talking about programming languages in this context. And you might say that, so polyglot programming is writing software in many languages or multiple languages. And you might say that if you're doing JVM web development, you're doing polyglot development. Because if you're doing any JVM web development, you're probably using Java, you're probably using HTML and CSS and maybe some JavaScript, maybe SQL or HQL. So that there's a bunch of languages right there. And that's fair enough. That is a type of polyglot programming, but that's not the type of polyglot programming that I want to talk about. So the type of polyglot programming I want to talk about is writing maybe considerable logic in your program in fundamentally different programming languages. So for this context, things like CSS, that doesn't count, right? I'm talking about languages like Groovy and Java and Clojure and Scala and Kotlin, languages that you might implement significant pieces of your application logic in. So Wikipedia says something like this. I won't read that to you, but that's part of Wikipedia's definition of what polyglot is about. What I'm going to talk about is consistent with that, and that is we're going to talk about using the Grails Framework in particular to build JVM web apps that could be implemented in maybe you might be using numerous programming languages to build those systems. That's the kind of polyglot that I want to talk about. It turns out that there are lots of languages that have been written for the JVM. This is a small subset here. There are hundreds of programming languages that have been written for the JVM. Now, many of those languages are folks' academic projects that you'll never hear about and you wouldn't consider for using for serious application development. But even if you got rid of all of those and just considered or looked at the list of languages that you might use for real application development on a potentially a fairly large scale, there's probably a dozen or so languages, right? Some of them are listed here: Java and Groovy and Clojure and Scala and JRuby, and there's about that many more that we might add to that list. The point being that there are lots of languages, there are a number of languages anyway, that have been developed specifically to target the JVM. Groovy is an example, right? Groovy was designed from the beginning to target the JVM. It was designed to have really slick interoperability with Java, and we definitely have that, right? You've got the seamless bidirectional interop between Java and Groovy, so you can write Java code that creates instances of your Groovy code and calls. You can make calls directly from Java to Groovy, and the same thing is true the other way around, of course. From your Groovy code, you can create instances of Java classes and make method calls on those things. And from both ends of that communication, the code looks natural. It's idiomatic for whatever end the call is coming from. So for example, when you're writing Groovy code and you're making a call to Java, it just looks like Groovy code. You can't tell that you're calling into Java code. And the same is true the other way around. From your Java code, you can create instances of Groovy classes and interact with them. And the code that you're writing to do that, it just looks like Java code. So in particular, what you don't see is any sort of bridge layer, any kind of dongle where you have to enter into you're writing Java code and you want to call some Groovy code, you don't have to switch into some different context or some different mode and write code a little bit differently because you're calling into Groovy code. Groovy and Java were designed, Groovy in particular, Groovy was designed specifically to have really, really seamless interop with Java, and we have that. Some of these other languages, like Clojure, for example, doesn't have that. You can definitely call into Java code from Clojure, and they provide a syntax or a way to do that. And you can call into Clojure from Java. We'll see a little bit about what that looks like. But it's not that, at least by default, it's not going to be that seamless interop. When you're writing Groovy code or Java code to call into Clojure, you see Clojure-y stuff there, right? And again, we'll see what that looks like. We don't have the same kind of seamless interoperability there. And there are reasons for that. That's not a criticism of Clojure, but it's a fact. So one of the things I'm going to demonstrate is some features of the Grails framework that can address that and can make, we're going to build a system and look at some code where we're going to have Groovy code calling into Clojure from a Grails application, and it's going to look very, very natural from the Grails end. It's going to look just like Groovy code calling into something, and you won't necessarily even know what the something is, and it'll happen to be Clojure. And in order to get there, we had to take advantage of a number of interesting features of the framework that I'll spend some time talking about. So there are lots of languages available for the JVM. There are lots of reasons that the JVM is a compelling place to deploy your applications, right? People want to deploy applications to the JVM. There are a number of languages available, and all these languages have their strengths and weaknesses, and they all have a reason for existence, right? Clojure is a great functional programming language. It does things in a very different way than OO languages like Java and Groovy, but there's some really interesting aspects to the Clojure programming language. And most folks would agree that there are certain kinds of problems that are really well served by a language like Clojure, better served than with a language like Java, for example. So it might be the case that you want to take advantage of all the great stuff that a language like Clojure has to offer, but you also want to take advantage of languages like Java and Groovy. And maybe even more specifically, you want to take advantage of what the Grails framework has to offer. So if you had to make a choice and say, I either get to take advantage of all the great stuff that Grails has to offer, or I get to take advantage of what Clojure has to offer, that wouldn't be ideal, right? You don't want to have to give up Grails just so you can use some stuff in Clojure, and the other way around is true as well. So the same kind of, we're going to see, and I'm going to demonstrate that you don't have to do that, right? You can take advantage of everything that Grails has to offer, literally everything. You don't have to give anything up, and in addition to that, we can take advantage of whatever it is that Clojure has to offer. So the JVM is this great place. We've got lots of languages that target the JVM. Separate but related from that, we've got the Grails Framework. The Grails Framework is a really, really powerful, really compelling platform for building web applications for the JVM. It's a full stack framework. It's built on top of proven staples like Spring and Hibernate and a number of other technologies. And an important part of the Grails story is the extensible plugin system. There have been something like 1,500 plugins, something like that, developed for Grails since we introduced the Grails plugin system, which was introduced in Grails 0.4. The great majority of those plugins have been developed by members of the community, right? So we develop a bunch of them, but the great majority have been developed and maintained by the community. That plugin system is a really, really important part of why the Grails framework has been as successful as it's been over the last decade. And Grails is a little over 10 years old now, which I think is impressive. So the plugin system is going to enable a number of the things that I'm going to look at and demonstrate today. So Grails is this really powerful full stack framework. It's built on top of a bunch of other best of breed technologies. And one of the things that Grails does is it makes it very easy and very simple to take advantage of these technologies, right? So you get to take advantage of Spring's dependency injection and not necessarily have to write much Spring code. You get to take advantage of all kinds of cool stuff that Hibernate has to offer and not necessarily have to write a bunch of Hibernate code. One of the things that Grails does, and the plugin system in particular contributes to, is the framework makes it easy for you to take advantage of these other technologies without necessarily taking on what otherwise would be part of the cost of using those technologies. And configuration is often one of those costs that Grails does a good job of eliminating, or at least lessening. So we're going to do the same sort of thing, not with libraries like Spring and Hibernate, but we're going to take a look at doing the same sort of thing for integrating with languages. And I'm going to use Clojure as an example, but fundamentally what I'm going to talk about, we've got the same kind of interoperability with Scala. We could have the same kind of interoperability with Kotlin. The fact that we target the JVM means we get we get a whole bunch of benefit from targeting the JVM, and one of those things, one of the benefits of being on the JVM is that we get access to all these great programming languages that have been developed for the platform. Right, so Grails is built on top of these other technologies. It all targets the JVM. Grails doesn't target any other platform. Every Grails application ever has always run on the JVM. And Groovy is this kind of dynamic thread that we use to tie all this stuff together. And that dynamic nature of Groovy is going to be a key part of some of the features that I'm going to rely on today, or demonstrate today, that we're relying on in order to achieve that seamless interoperability that I described between Grails and a fundamentally different programming language like Clojure. So we've got this really great programming language, Clojure. We've got this really great framework called Grails, and we want to put these things together and take advantage of everything that both of them has to offer. We want to tie that all together, make something that's maybe better than, where the sum of the parts is more valuable than the individual things, right? So we'll start by looking at some simple code here. So we've got a controller in a Grails application. Of course, this code is written in Groovy, and there's a controller action here called sum. It grabs the values of a couple of request parameters, passes them off to some helper that does something with those values, and we get a value back, and then we can do something with the value. So all we're doing here is passing some numbers off and getting a sum. But the part that we want to focus on really is on line 11. We're calling into this thing that's going to do some work for us. That's really all that's important. The fact that the work happens to be addition isn't, don't be distracted by the simplicity there. We're calling off into something else. We're going to get back a result. So how many languages are involved in this code? Just shout out a number. How many languages are involved there? Two. Well, so one, there's at least one, right? There's a language we're looking at, and that language is Groovy. So we'll say that there's definitely at least one. So someone said two. What is a non-Groovy language that's involved here? I heard several people say two. What was the other language you had in mind? Scala? So there's no reason to believe there's Scala involved there, but there could be, and that's really part of the point, is we don't know from looking at this how many languages are involved. So params, we don't know what params is, right? It'd be easy enough to find out if we were in the IDE, but you don't necessarily have to know what language that params object was written in. You don't have to know what type it is, right? What you really have to know in order to interact with the params object is sort of what does it provide, right? It provides a method called int, and you can pass a string as an argument, and what params is going to do is retrieve the request parameter whose name is that value. So it's going to retrieve the request parameter whose name is x, and convert that request parameter to an int and return that value, right? So I have to, in order to take advantage of that, I have to know that there's an int method, and I have to know how it works and what I pass in and what to expect back. But specifically, one thing that I don't have to know is what language is params written in. And I expect that most Grails developers who write code that interacts with params all the time probably don't know what language params is written in, or what it's an instance of. And that's actually a good thing, right? That you don't have to know that. So we don't know what language the params objects class was written in. We also don't know what language the math helper was written in, right? We've got a property in this class called math helper. It happens to be dynamically typed. Even if it was statically typed, even if that said math helper with a capital M space math helper, statically typed, we still wouldn't know what language it was written in, right? So the dynamic typing isn't really the issue here. What we need to know about the math helper is that one, that it's called math helper, and that there's a method called add numbers on it, and I pass in a couple of numbers and I get a result back. I need to, just like with the params.int method, really all I need to know about the math helper is what can this thing do for me? It's got an add numbers method that accepts 2 ints and returns an int. I don't have to know what language the math helper was written in order to write this code. Right? Now someone's going to have to write the math helper. That person decides what language they want to write that thing in. If they're going to write that thing in Scala, then that person needs to know Scala. But in order to do that, they don't have to know Groovy, right? They don't have to know this language that we're looking at here. So we're going to put together all the pieces of the puzzle here, and we're going to see how these things really get tied together. But we'll start with this idea that we've got this polyglot controller that's written in Groovy. So somebody has to know Groovy to write that. And then the math helper is written in some language, and whoever wrote that needs to know that language. But the two aren't necessarily the same. And in order to write either end of that communication, you don't necessarily have to know anything about the language at the other end. And that kind of seamless interoperability is a good thing, right? We want to. That's a good thing to strive for, and we've accomplished that, and we'll see how. So let's drill into that a little bit. So we don't know what language the math helper was written in. So it might be written in Java. It might look like this, right? So we've got a class called mathhelper.java. And it's got a public method in it called add numbers. You pass in a couple of ints and you get back an int. So back here in the controller, that thing that we're interacting with on line 11 very well could be an instance of this. So let's say that's the case. So we write both those classes, the system's in production, all is cool. And then for some reason, at some point in the future, instead of writing this helper in Java, we want to write it in Groovy. So we rewrite the thing in Groovy. And again, we've got a trivial example here that's just doing addition, but maybe there's lots of complexity in this thing. So we rewrite it in Groovy, and one of the interesting things about that process is that we won't have to come back here and change this. Right? This code doesn't know or care what language the add numbers method is written in. This code is simply calling the add numbers method, and as long as part of this refactoring where we migrate this Java code to Groovy code, as long as during that process we don't change what the API looks like, then we'll get away with that, right? We won't have to change this class when we rewrite this Java helper in Groovy. Does that make sense? All right. So Java and Groovy are pretty similar, so that seems like, yeah, that's neat, that's convenient, but it's not terribly impressive that I could replace Java code with Groovy code and get away with that. But the add numbers method might be written in a more fundamentally different programming language. So for example, maybe it's written in Clojure. And you don't have to know Clojure to follow along from this point. Just that's valid Clojure code there. And what that Clojure code does is it defines a function called add numbers. The add numbers function accepts 2 parameters and returns their sum. And we really don't even have to know that much about it. But what we do need to recognize is that there's a function called add numbers that's been written in Clojure, and somehow we could configure the system such that that's what we're calling from here. And the ability to get to here from Groovy in a very, very natural way, which is what line 11 represents. That doesn't look like there's no bridge or dongle there that's going off into Clojure land. We're just calling add numbers on our helper, and we're going to get something back. And we're going to explore some features of the framework and the language that make it possible for that to happen. Right? This code right here could very well be calling into this Clojure function. And again, so we migrate the add numbers method written in Groovy to Clojure, and we won't necessarily have to change any of this code to move forward from that point. So let's explore what it will take to make some of that happen. So what I've got right now is a simple application that is going to allow us to explore some of that. And in this project, what I want to do is I want to write a Groovy math helper that's going to look just like it's going to look a lot like the one that we just saw on the slides a moment ago. Right? Looks something like that. And I'm going to put an instance of that class in the Spring application context as a bean. And the way to do that is, or a way to do that is here. I could say math helper, Groovy math helper, just like that. Now there's going to be a bean in the Spring application context whose name is MathHelper, and that bean will be an instance of Groovy MathHelper. And let's start the application up. And while it's starting up, we'll go take a look at a controller that exists in this project. That is our math controller. And the math controller has a property called MathHelper in it. And Grails developers know that all of your Grails artifacts are automatically subjected to dependency injection. And when that happens, the dependency injection is carried out using AutoWire by name. And what that means, this is all Spring taking care of all of this. And what that means is if there's a property in this class called MathHelper, and there's a bean in the Spring application context whose name is MathHelper, Spring will inject that bean into this controller without this controller reaching out and expressing directly. So we don't want this, right? We don't want to create a new Groovy MathHelper. That's a bad idea. A better idea is to have that dependency injected into this controller, and there are a number of benefits to that. And one is that in order to get there, I don't have to know the type of thing that I'm interacting with. I just need to know that there's going to be a MathHelper in the Spring application context, and that MathHelper will have a method in it called addNumbers that accepts a couple of values and gives me back something helpful. And I just changed that class while the thing was running. Let me see here. Start that. So what we're going to see when I get this thing running is we will have, in fact, I'll do this like that. All right. What we're going to see when I get this thing up and running is we're going to have a form in the browser where I can enter a couple of numbers and click go, and this function is going to be called. And the way it's written right now, we're not calling into the Groovy function, we're calling into the Clojure function. But bear with me, we'll get there. And as soon as that's up, we'll be able to send a request to localhost 8080/add, I think is the URL mapping. Nope, it's add is the one that I want. Just waiting for the container to start up here. This is the action that we're invoking initially. All right, so we'll do that. We get this form. I can enter a couple of numbers, click add numbers, and that says the sum of 4 and 7 is 11. So the system appears to be behaving, right? So we enter a couple of numbers, click add the numbers, we get back the sum of those numbers. So from looking at this code right now, again, we don't know what type of object we're interacting with there. It could have been the Groovy MathHelper that we just wrote. I've skipped forward a step. So right now what we're actually doing is we're calling into some Clojure code that is this. And I'll demonstrate that by changing this code. So I'm changing the Clojure function to return not only the sum of x and y, but the sum of x, y, and 1,000 is what I just did. And now if we do this again, we see 1001. So that the sum is 1001. That's evidence that we really are executing this Clojure code. So what I want to demonstrate is how we get there, right? So somehow that line of code is leading us to execute that Clojure function. So I'm going to jump into the source code of the Clojure plugin and point out some things that will make it more clear how this is happening, and that will enable us to explore some features of the Groovy programming language and the framework, the Grails framework, that are conspiring to make that possible. So remember that we don't know what type of object the MathHelper is, right? We just need to know how to interact with it. It's got a function on it called addNumbers. In the Clojure plugin, there's code that does this. And what that's doing, and I'll simplify this a little bit, make that not dynamic. We'll say effectively that's what's happening. So the Clojure plugin is creating an instance of a class called Clojure Proxy, which we'll look at in just a second. But that's a class that's part of the Clojure plugin. and adding a method to all Grails artifacts. So classes in this context is going to be a list of all of your controllers, all of your services, all your tag libs, all your quartz jobs, your domain classes, all of your Grails artifacts. And for each of those Grails artifacts, we're going to add a method called getCLJ to those classes. So inside of my controller, I could refer to CLJ and invoke certain kinds of methods on that thing. And the thing that I'm interacting with, that CLJ property, is actually going to be an instance of that class. It's going to be an instance of Clojure proxy, but as I'm writing this code, I don't want to know that. I don't want to care about that, and I definitely don't want to do this, right? I don't want to have a specific dependency on the Clojure proxy. There are times when statically typing properties like this make sense, and in general, by default, I say it's a better idea to statically type properties like this. But in this particular case, we've got a specific reason not to want to do that. We'll be, as we press through this, that'll become more and more clear. But we've already kind of seen that, and that is that I don't want to know what type of object that is. I just want to know. I just need to know how to interact with that. So that CLJ property, I could do this. I could say clj.addNumbers, and the thing would work the same way that it is now. But instead, I'm referring to this math helper thing. And the way this works is the plugin provides support for you. If we go back and look at this CLJ function, this addNumbers function, notice the very first line of code in this Clojure source file says nsmath, ns for namespace. And that's Clojure syntax for declaring the namespace for all of the functions that are in this file. And namespaces are like packages in Groovy or packages in Java. So I might have one file that has an addNumbers function that's in the math namespace, and then I might have a whole different source file that defines another addNumbers method in a different namespace. Just like you can have two methods called foo in two different classes, in Clojure I can have two functions called addNumbers in two different namespaces. So this function is in a namespace called math, right? That's what we've expressed there. And in our application.yaml file, I've got config code that looks like that. So grails.clojure.namespace beans is the root of this, and then the value that's associated with namespace beans is this map that could have any number of entries in it. Report helper. And the way this works is the plugin is going to create a bean with this name and add that to the Spring application context, and the bean will be an instance of that Clojure proxy thing, that Clojure proxy class that we saw a reference to a moment ago, and we'll look at the source code for that class in just a minute. But the math helper bean will be an instance of the Clojure proxy class, and that Clojure proxy class will be associated with all of the Clojure functions that are in the math namespace, right? And then I don't have a reporting namespace, but if I did, I could add another entry to this namespace beans map and have a different bean name, report helper, that's associated with all of the functions that are in the reporting namespace. So we'll get rid of that because we don't really have that. But the plugin provides support for this, and that is you can map function namespaces to bean names, and you just make those up, right? Math helper could be anything. And that causes a bean with that name to be added to the Spring application context, and that's the bean that's going to be injected into this property. So this is really a call to add numbers on an instance of that Clojure proxy class, right? And the Clojure proxy class is provided by the plugin, right? You didn't write that. The application developer didn't write that. The plugin provides that Clojure proxy class, but somehow I can invoke a method on that thing, and the result of that will be that a function with that name that's written as part of my application gets executed. Right? We've demonstrated that this code that's in the project in the application is being executed as a result of this. But this thing is an instance of that Clojure proxy class. So somehow there's another piece of this that we haven't seen yet. Right? So if we look inside the Clojure proxy class, we won't find an addNumbers method in here. That wouldn't make sense. Right? The Clojure proxy class is part of the Clojure plugin that we're using. The addNumbers function is something the application developer wrote, right? So something's got to give here. Right here, we're invoking the addNumbers method on the Clojure proxy. What's going on? And this method missing is a key part of that. So Groovy has a really flexible dynamic dispatch mechanism. Every method call, at least by default, every method call that you ever make from Groovy, and it doesn't matter if you're calling to Java or Groovy or Scala or any other language, if the method call is coming from Groovy, by default, that method call goes through Groovy's dynamic dispatch mechanism, known as the MOP. MOP is Meta Object Protocol. But so think of it as this dynamic dispatch mechanism. And it's that dispatch mechanism that decides where method calls get handled. And a part of that dispatch mechanism is that Groovy will recognize if you write a class that has a method in it called method missing, and the signature is what you see there, then you could create an instance of this class and call any method at all on it. Call a method named foo. And you will not get a missing method exception because Groovy will try to find a method called foo in this class, won't find it. But instead of throwing a missing method exception, Groovy will recognize that this method missing method is here, and Groovy will invoke this method instead of throwing an exception, and now the author of this method gets to decide what to do. Many of you are probably Grails developers, and if you're a Grails developer, you're probably familiar with things like dynamic finders. So if you have a person domain class, you can invoke person.findAll by age greater than, and then pass a number and you get back some subset of your data. That findAll by age greater than is not a real method that you'll find any place in your project. And the way that works is Gorm is adding a method missing to all of your domain classes. And what that method missing is doing is intercepting calls to methods that don't exist. And then we've got this whole sophisticated thing that parses the method name and figures out what you're trying to express, right? Find all by, okay, so we know that you're trying to express a query. So then we parse the rest of it, age greater than. And Gorm knows what to do with that, right? So Groovy makes it easy for you to intercept calls to methods that don't exist and then do something meaningful with that interception. And that's what's going on here. So back in the application, when I invoke add numbers on that instance of Clojure proxy, what I'm really doing is I'm invoking a method that doesn't exist, right? There is no add numbers method anywhere. Right? There's a function that I wrote out here, but that's not in play yet. Right? I'm invoking a method that doesn't exist. The Clojure proxy is intercepting that method call by way of having this method missing method in it. This business right here is just Clojure specific stuff. I don't want to spend too much time talking about that, but at a high level, what's happening here is the Clojure proxy is looking at the name of the method that you invoked, add numbers, and then reaching into the Clojure runtime to find a function with that name, right? And then executing that function. And that's what's going on right here. That's the bit that's really calling into the Clojure runtime and invoking the function. This is that layer that I said we really don't have seamless interop between languages like Groovy and Clojure or Java and Clojure. This doesn't look like idiomatic Groovy really. This looks like we're interacting with some library that's going to go do some work for us, as contrasted with this, right? This just looks like we're invoking a method on some object. This just looks like regular Groovy method call stuff. But because Groovy and Clojure don't have that same kind of seamless interop, this little contraption here is the tedious bit that it takes to get from one to the other, and we want to get rid of that, right? We can't really get rid of it, but we can encapsulate it here in a way that allows you to do this, right? So you get from the application developer's perspective, all that tedious stuff or whatever it takes to call into Clojure, you don't have to know. You have to know how to write Clojure, or somebody does, right? Somebody has to write these functions, and you have to know how to write Groovy to write this code. But what you don't have to know is these tedious bits here, which is really just the API for calling into Clojure from Java. Right, so the Clojure proxy intercepts the method call and then does this stuff to call into the Clojure runtime and eventually lead to this code being executed. Right. Does that make sense, at least at a high level? Are there any questions or comments about any of that? Is there a hand? Yeah, go ahead.
Is this compiling Clojure on the fly?
The question is it compiling Clojure on the fly? And it is. Well, not on the fly in that it's not compiled at invocation time, but it is compiled at application startup time and later. So one of the things that the Clojure plugin is doing is it's watching all of your Clojure source files. That's what We're in the source code for the plugin now. It's watching all of your Clojure source files. So when you change a source file while the program is running, remember I put this 1000 in here, and that dynamically reloaded. The reason for that is the plugin is watching those source files, and when one of them changes, this gets executed. And what this is doing is asking Clojure to recompile that Clojure source file. So it's the Clojure code's being compiled. It's being compiled on the fly in that it's happening dynamically. When you start up your application, the stuff gets compiled, and then when you're while the program is running, if you change Clojure source code, it gets recompiled. But it's not on the fly in that every time you call the method, it doesn't get recompiled. Does that make sense? Good. I think I saw a thumb up there. Yeah. Any other? Yes, right here.
I think it's really impressive. I was wondering if there was any way to declaratively announce the interface that you're trying to create as a contract between the client and the external language. If you tried to do it, or if it proved too difficult to implement.
Yeah, so the question is about is there a way to declaratively express the contract, right? What functions or what methods is this thing going to provide? And all the pieces of the puzzle are there to do that. We could do some interesting things with AST transformations. So I can see almost all of that just thinking about it for 10 seconds. But the plugin doesn't do that. There's no support for, there's no interface generation, nothing like that. But it certainly could be done, right? The system could dynamically discover, either dynamically or I guess you'd want to do it ahead of time or it wouldn't make sense. The system could evaluate your Clojure functions and then generate interfaces and then dynamically have the Clojure proxy thing implement those interfaces. So back here in your controller, conceivably you could have something like that, where Math Helper is an interface that defines these contracts. That's one way maybe that you could go about getting there. There are other ways you could do it, but the plugin doesn't do anything like that, right? Which is why this has to be dynamically typed. I mean, we could do this, but it'll still work, but that doesn't. There's no real benefit to doing that. We're not going to autocomplete. There's really no benefit to doing that. Other comments or questions about any of that so far? Right? So all the plugin is doing, or not all but one of the things the plugin is doing is intercepting these calls to methods that don't exist and then routing them to the Clojure runtime. So now with that, with this application using the Clojure plugin, you can write as much Clojure logic as you like. You could have the great majority of your application written in Clojure and then define some namespace beans using this thing here, and there can be any number of those beans, right? You could have 100 of them or more, any number of them, and then go about your business in the web layer, doing stuff like this, and then calling out into the Clojure code. So if there are parts of your system that would benefit from some features of the Clojure programming language, you can implement those parts of the system in Clojure, and then still get to take advantage of everything that Grails has to offer. Right? Does that idea make? And that's really the big part of the point here. Does that make sense? I think that's the sound of Pac-Man starting, right? All right, so we've been able to tie all this stuff together. We get to take advantage of everything that Groovy has to offer, everything that Clojure has to offer, everything that Grails has to offer. And it's really all of these things in this list are all conspiring together to make that possible. It's not the case that Grails is really what's making all that possible. Grails is relying on, one, the JVM, right? This place where all these programming languages exist. Grails is definitely relying on a bunch of cool features of the Groovy programming language to make this very simple and easy to do. Clojure certainly gets at least part of the credit, right? They built this language that does some interesting stuff. And as it relates to this conversation, the important part is that they provided a mechanism for calling Clojure from Java. Right, and that's this bit right here in the Clojure proxy class. If there was no API for calling into the Clojure runtime, then we couldn't do this, right? Or we'd have to build that API. So the Clojure folks not only built this really interesting programming language, but they provided a mechanism for calling into that programming language from Java. So certainly they get some of the credit. None of this would exist without Java and the JVM. So all these things are conspiring together to create the possibilities that include what we're talking about, and that is we've got what we're left with once this plugin was written is we can tie all this stuff together and use Clojure and Grails, and it all just plays together really, really well. There's no remember that the complexity, this business right here, that's provided by the plugin, and this is a common thing that turns up in plugins all the time, and that is there's some tedious stuff. So the plugin can do the tedious stuff for you, and what you're left with from the application developer's perspective is simplicity, right? None of that complexity manifests here, and none of that complexity manifests here. Here I'm just writing Clojure code and doing whatever Clojure is capable of. Here I'm just writing Grails Groovy code and doing whatever Grails and Groovy are capable of, and all this complexity was taken care of for me by the plugin. And as I said, it turns out lots of plugins do that same sort of thing. So thoughts or questions, comments, criticisms, doubts, anything at all about any of that? Right here in the front.
You have to call the method add numbers now with the underscore instead of the camel case version. Would you recommend that in Clojure we?
Yeah, so we could argue about what's really the best practice here. I think probably a better practice is to do this, and call the thing add numbers. This is not idiomatic here. Now it's a little bit funky, right? Because we've got function names that are not in Clojure. I expect most Clojure developers would look at that and think that looks goofy. That looks like a Java developer wrote that, which is not ideal, right? This would be ideal, but in order to do that, now we're in this mode. So maybe a good idea for the plugin is to do some name mapping, where we could turn function names with underbars, snake-cased function names into camel case method names, and that'd be trivial. Really where that would happen is here. In the method missing, when the thing intercepts a call to add numbers with an uppercase N, there could be a simple string utility that can take that camel case thing, map it to snake case. That's a perfectly reasonable thing for the plugin to do, and maybe it should. But without that support, we've got to make a small compromise at one end here. We're either got goofy names at this end, that's not idiomatic, right? Or we have to have a goofy name at this end that's not idiomatic. Neither of them is a huge problem, but that's something that the plugin could do better. Anyone else?
With this technique, we can inject a bin with the code from another JVM language and use it. But I can, for example, like write my full controller in Clojure and use it because it's not injected as a bin, so I can't use do.
Yeah, it's true. I think the comment is that this allows me to write parts of my system in Clojure and call it from a controller, but I can't write the controller in Clojure, and that's true. Again, the plugin could support that. It doesn't, but I would submit that that's not a great example of something the plugin should do. There's probably not a great reason to want to write a controller in Clojure. The controller is doing. It probably makes sense to use Groovy at this layer and provide a simple access to calling into Clojure code. But the bottom line is the plugin could provide a mechanism for you to write controllers and services and other artifact types in Clojure. It doesn't, and I'm not sure that would be necessarily a good thing anyway.
Yeah, maybe then pick a Clojure web framework or something.
I'm sorry, I didn't hear the end of that.
Yeah, so maybe if you want to do that, maybe instead take a Clojure web framework because you are doing everything in Clojure.
Yeah, if you want to write the whole thing in Clojure, you might. I mean, so you might end up with no justification for using Grails, right? So you might want to use a Clojure web framework.
Thanks.
I submit that the web framework space for Clojure is nowhere near as robust and rich as something like Grails, which is why this is valuable, right? I want to build a Grails application, and I want to take advantage of what the Clojure programming language has to offer.
Is there a public repo for this?
For the plugin, there is. It's a public plugin, so the source code is out at GitHub. Under the Grails/plugins organization, and the plugin, the binary is distributed at Bintray, where all of our plugins are distributed. So it's a public plugin, and just quickly, I'll show you in my build file. We've got this. I'm using the plugin is in an RC state right now, but that's a dependency on the plugin. It's out there. You can put that in a Grails 3 project today and go to town and do what the plugin, take advantage of what the plugin has to offer. So it's definitely a public plugin. It's out there, and it works. We've got time for just one more question.
Okay.
Go ahead.
I was wondering, we've seen the example about Clojure. Is there any other integration for any other language, such as Scala, for example?
There is integration for Scala. I don't know Scala, and I never monkey with the Scala plugin. I don't even know what it looks like. I just know that it exists. And for other languages, it'll depend on what the integration that Java has with those languages is. So, for example, with Kotlin, you really don't need any special plugin to take advantage of Kotlin in a Grails application. There's a Kotlin Gradle plugin. You can install that, and now you can have source main Kotlin or whatever the Kotlin source directory is, put your Kotlin stuff there, and they're just class files that you can use in your Grails application just as if they'd been written in Java.
Thank you.
Sure. So it's we're a couple minutes over. I'm happy to talk with folks as long as you like. I'll be here the rest of the day, and definitely come see me at the OCI table if you like. But I don't want to hold folks up who are anxious to get to lunch or whatever is next. Come see me if there's anything I can help you with. Thank you all very much, and hope you enjoy the rest of the afternoon.